Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about one-to-one functions and their inverses. So a function is one-to-one if different inputs have different outputs. For example, in the mapping diagram, if we draw, let's say this is domain and this is range. So if I have A, B, and C, so each of these are they are mapped to different outputs. Okay, so if that happens, then a function is one-to-one. So for example, this function is not one-to-one. For example, so let's say this is domain, this is range. I have A, B, and C. I have 1 and 2. A is mapped to 1, B is mapped to 2, and C is mapped to 2. So this is still a function because each input has exactly one output, but it's not one-to-one function. Because because two different inputs. Okay, so here, sorry, A and C, the two different inputs, they have same output 1, so this is not one-to-one. Another way to check this one is it has to be function if we reverse the order. So for example, if I go from this set to this set, this is a function because each input has exactly one output. Now, if I reverse the direction and if I go this way, this is also a function. So that means it's one-to-one. But here, when I go from this set to this set, it's a function because each input, they have exactly one output. But when I reverse the direction, when I go in this direction, now one has two different outputs, so it's not a function. So that's another way to check this, okay? So this is the mathematical definition. If the inputs are different, the outputs are same. Or in other way, we can also say, if the outputs are same, then the input must be same, then the function becomes one-to-one function. Let's go ahead and prove this is not a one-to-one function. So in order to prove that a function is not one-to-one function, we can just find a counterexample. We can just find two different outputs, two different inputs such that their output is same. So for example, here we can do we can take f of -2, which equals -2 squared, and that gives us 4. Now if I find f of 2, again that is 2 squared and gives me 4. Now I took two different input, -2 and +2, but the output was same. So for two different inputs, I have same output. That means this function is not one-to-one. So this proves that it is not one-to-one function. Sometimes, yeah, to prove it's not one-to-one, it's easy, but sometimes to prove that it's one-to-one, it might be a little bit challenging. We can do that algebraically, but more often we use a graphical test, which is called the horizontal line test, to show that whether a given function is one-to-one or not. So this is the horizontal line test. It says that if no horizontal line intersects the graph of the function f in more than one point, then the function is one-to-one. So for example, if I have the function that we looked at in the previous example, the squared function, f of x equals x squared. Now it is possible to draw a horizontal line that intersects the graph at more than one point. So this is not one-to-one. For example, if I have a graph like this, now for this graph, it's not possible to draw a horizontal line to cut the graph in more than one point. So this is one-to-one function. So that's easy check for the function whether it's one-to-one or not, okay? So now let's look at these examples here. So we are given three different graphs and we are asked to determine whether this graph represent one-to-one function or not. Okay, so the first one, I can draw a horizontal line such that it intersects with the graph of this function at three different points. So right here, and right here. So this is not one-to-one. Here, this is a graph of square root function. So here it's not possible to draw a horizontal line to cut the graph in more than 1 point. So this is 1 to 1. And here it's the same thing. We cannot draw a horizontal line to cut the graph at more than 1 point. So this is also 1 to 1. Now, the importance of one-to-one function is if a function is one-to-one, then the inverse is also a function. Okay, so if it means if it is a function in this direction, then if it is one-to-one, then it is also function in the opposite direction. This is the inverse. Inverse means we go from range to we switch the direction. Okay, so if a one-to-one function has an inverse, then we denote the inverse by this notation here, which is read as f inverse. What happens is f is a function going from, say, domain to range in this direction. Then the inverse goes from the range of f to domain of f. Okay, so this is the inverse. So now for the inverse, this becomes the domain and that becomes the range. So domain of f is the range of the inverse, and range of f is the domain of the inverse of f. Okay, and then there's one important result here. The composition of f and f inverse is always 1. So if we do that composition, it's always x. This is why, because remember we talked about the composition function in the previous video. So composition function means we have two different functions. So let's say f and we have f inverse. So what happens is when we send x through here, we get f of x. Now doing inverse means it's just like undoing whatever this function or this machine did. So when we undo that, we get whatever we send from here. We get x out here as well, and it's true in the opposite direction as well. So that is what this composition of these two functions, the function and its inverse is always x. Now, if a function is one-to-one, we say that the inverse is also a function. Now, how to find the inverse of a function? So that's what we are going to discuss. So there are mainly 4 steps that we are going to do in order to find the inverse of a function. First, we are going to replace the notation of the function f of x with y, or g of x, or h of x. So whatever notation you have, we are going to replace that notation of the function by with y. And then next, we'll switch x and y. So the reason for doing that is when we are finding inverse, the domain becomes range and range becomes domain, or the input becomes output and output becomes input for the inverse function. So basically, we are going to switch the independent and dependent variable. Okay, so we are going to switch x and y. That means wherever we see x, we are going to change them to y, and wherever we have y, we'll change it to x. Okay. And the next step is we'll solve for y. And the final step is we'll replace y with the inverse notation. So let's go ahead and do this problem. So it says first check whether the graph represents one-to-one the function or not. I mean, the given function are one-to-one function or not using a graph. And then we are going to find the domain, and we are going to study domain of the function. I mean, we are going to find the inverse, and then we are going to state the domain and range of the function and the inverse. So I have already drawn the graph here. So graph of this cubic function is right here. So it does pass the horizontal line test. There's no way we can draw a horizontal line to cut that graph in more than 1 point. So that means this is one-to-one function. The next thing, let's go ahead and find the domain of this function before we find the inverse. So domain of this function, this is a cubic function, and clearly even from the graph, we can see that this goes forever on both directions. So the domain is all real numbers. And range is also all real numbers. Now let's go ahead and find the inverse. So to find the inverse, we have 4 different steps. The first one is we replace f of x with y, and then we write 2x cubed plus 5. The second step is we'll switch x and y. So let's go ahead and do that. That means this y becomes x, and then that one becomes y. then we have plus 5. Now the final step is we are going to solve for y. So in order to solve for y, first we subtract 5 from both sides. So we get 2y cubed equals x minus 5. And then we divide by 2. So we get y cubed equals x minus 5 over 2. Then we take the cube root. So we get cube root of x minus 5 over 2. And the final step, we write the notation for the inverse function, which is f inverse x equals cube root of x minus 5 over 2. So this is the inverse of the given function. Now we have to find the domain and range for this inverse. So remember, the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. They just switch. So we already have the domain and range for the function. So for the inverse, domain is this range, which is all real numbers, and then range is the domain, again, which is from negative infinity to infinity. So now let's look at another function here, this square root function given. We already have the graph. So looking at the graph, we can say that this function does pass the horizontal line test. So it is one-to-one function. So before we find the inverse, let's go ahead and find the domain for this function. So clearly from the graph, we can see the domain starts from here, which is 1.5, sorry, which is 1/2. And then this is the domain, and the range is from here above, okay? Um, but now, instead of looking at the graph, let's do it algebraically. So we know that it's a square root function. So in order to find domain, we take this quantity inside the square root and we set up this inequality, um, which says that the quantity inside the square root must be non-negative. So let's go ahead and solve this inequality. So we add 1 on both sides. So we get 2x is greater than or equals to 1. Then divide by 2. So we get x is greater than or equals to 1/2. So the domain is the interval. So from 1/2 to infinity, and 1/2 is included. Okay. Now for the range, we can just look at the graph, or we can also say the smallest number that come out of this square root is 0. We cannot get negative numbers from there. So, and the largest one is, as we increase x, the domain increases, the output increases. So that means it goes to the infinity, okay? So that means the range is from 0 to infinity. Now let's go ahead and find the inverse of this function. So the first step, we are going to replace g of x with y. And the second step, we are going to switch x and y. So x equals square root of 2y minus 1. And the next step is we are going to solve for y. So we square on both sides. So we get x squared equals 2y minus 1. And then we add 1 on both sides. So we get 2y equals x squared plus 1. And then if we divide by 2, we get y equals x squared plus 1 over 2. So one important thing, just if you just look over here, it looks like this function is a, so before that, let's go ahead and write the notation. So this is the f inverse x, which is x squared plus 1 over 2. Now, if you look at this function, it's a quadratic function, and we think that the domain is all real number. But this function is just not the quadratic function, it is the inverse of this given function right here. So we have to, when we write the domain, we really have to be careful here, because the domain is not all real numbers here. Okay, so the domain is the range of this function, which is right here. So the domain is 0 to infinity, and the range is the domain of this function, which is 1/2 to infinity. So let's look at one more question here, one more function, which is a rational function. And we'll talk more about rational function later in the course, but now we are going to find the inverse of this function. So first, let's just look at the graph, okay, to find the domain and range. So domain we can find from here. So domain of this function are all x values such that x minus 6 is not equal to 0. Or we know that if we take x equals 6, this is going to be 0 or x equals 6 makes that denominator 0. That means 6 is not in the domain of this function. So to write domain, we have negative infinity to 6 union 6 to infinity. Now for the range, just look at the graph. This is a rational function, and then we do have a horizontal asymptote, which is y equals 2. So there's a line here, okay? And again, we'll talk more about that when we do rational functions later, but there's a horizontal asymptote. That means the function never gets to the value of 2. Okay, so it goes very close to 2 from both sides, but it never touches that horizontal line. So the range is from negative infinity, okay, it goes all the way down. So from negative infinity all the way to 2 union, and from 2 all the way to infinity. That is the range. Now let's go ahead and find the inverse. So first thing, we are going to replace h of x with y. So y equals 2x plus 5 over x minus 6. Now the next step is we are going to switch x and y, or we are going to replace y with x and x with y. So when we do that, we are going to get x equals 2y plus 5 over y minus 6. Now, in order to solve this one, let's get rid of that fraction. So what we are going to do is we are going to multiply on both sides by y minus 6, and that gives us xy minus 6x equals, in this side, this cancels out, so we have 2y plus 5. So remember, we are trying to solve for y. So we have a term with y right here, and we have another term with y right here. So we need to put them together. So what we are going to do is we are going to subtract 2y from both sides. And then we don't want that 6x, so we'll add 6x on both sides. So when we do that, we get xy minus 2y equals, we get 6x plus 5. Now we are trying to solve for y, so we cannot subtract this because these are not like terms, so we don't have like terms over here, okay? So what we do is we'll factor out y. And then we have y times x minus 2 equals 6x plus 5. And then if we divide by x minus 2, so we get y equals 6x plus 5 over x minus 2. That means the inverse function, okay, is 6x plus 5 over x minus 2. Now again, to find the domain, we'll just go back and look at the domain and range of this function. So the domain of this inverse function is the range of the original function. So the domain is negative infinity to 2 union 2 to infinity. And we see that from here as well. We cannot have 2 for that function. And the range is the domain of the original function, which is negative infinity to 6 union 6 to infinity. We'll just do this much for this video. I'll see you again in the next video.